Welcome to Retech, and today I was planning on doing Dr. T's music MIDI system, and it looks like it's quite a decent program. It's very well specified, and it looks like it would have been a lot of fun to do, but as these things kind of happen, the machine I was going to run on was the Amiga 600. I mean, it does work on the 5, and I assume the 12 and the Plus, but I was going to use the 6 simply because it's one of my kind of rapidly becoming my favorite Amiga, and also it's quite a small system, so when you start plugging in keyboards and everything else that you got to plug in for this piece of software to make it work, then it kind of takes up a lot of desk space. So the 600 was the plan, but it's as usual decided to die. It's decided to give up the ghost, as these things do with classic and vintage hardware. Now, I was kind of normally go out and grab another 600 to do this video, because I've been planning on doing this for a little while, but these are getting very expensive now. I don't know if you've had a quick look online, and you'll probably find that the Amiga 600, which was once the Amiga that nobody wanted, is going for quite a lot of money now, and it's actually worth repairing them and finding out what's gone wrong with them in order to repair them. So that's what I'm going to do today. Now, the downside with the Amiga 600 is that it's very difficult to actually do some service replaceable parts on one of these, because most of the board is surface mount, as you'll find out when we take a look, and because of this they're getting very difficult to repair, especially if you're going to do it as a home or hobbyist kind of repair. Now, you can, if you're very careful, replace surface mount components, and it takes a little bit of doing and it takes a little bit of time, but it is possible. But this machine, the way it died, it basically switches on, you get nothing whatsoever. You don't get anything at all. Now, I've checked the power supply pinouts and they're all fine. Checked the voltages from the power supply, that's all fine. So it leads me down the path of this Amiga 600 being internally faulty. Now, there was no warning signs. It basically was running fine, it worked as it should do, but then all of a sudden, when I turned it back on about 30-40 minutes later after using it, it just wouldn't power on. You would get a solid caps lock light. Now, I'm kind of thinking that immediately that is a processor fault, and if it is, we're gonna have a little bit of trouble. So I'm gonna take a good look at this machine to see if we can get it repaired. So let's take a brief look at the Amiga 600 and see if we can get this machine fired up instead of this no display, no nothing, blank screen. Okay, so let's take a look. Okay, so the first thing we really need to do is start taking this machine apart. So that's what we're going to do. So really, initially, I'm just going to spin it around and unplug the unit completely so we don't have any mishap. So spin the machine over and we're going to pop it down. And there's only a few screws to remove. Okay, once you do that, you got to gently prise the case off, and it has to move over to the right otherwise it catches on the drive. So make sure there's no discs in, and then we're just going to move it and pull the case off. And I'm just going to unplug the keyboard and then take the case out of the way because we don't need this part at the minute. Okay, next we'll just remove this shield. This is where the original hard drive would have sat. And what we're going to do is we're going to get the oscilloscope out. First thing we're going to do is make sure the RAM's seated. So it's got an upgrade on the RAM itself, and we're just going to check that nothing has become unseated. Now, there's very little you can do on these because once you find out that everything's correct on the voltage, you're going to have to check the pinouts from the CPUs, etc., to find out that it's working, and also make sure this is getting the correct voltage and waveforms. Once we've done that, we're just going to try and figure out what the problem is. So we're going to pull the oscilloscope onto the bench next. Okay, so we have the oscilloscope set up here. As you can see, it's running quite well. And what I'm going to do is I'm just going to check out the 68,000 CPU because I got a funny feeling that that's causing the issue. So I'm just going to go around the pins. There we go. Okay, we've got 1, 2, got no connect on there, so okay, that one's not right, that one's okay. What I'm looking for, oh, there we go, is a constant trigger, but this seems to be not very constant. Because the pins I was expecting to have some feed on actually doesn't have anything at all. So I do get the feeling that this 68,000 is the bit that's causing the problem, which kind of makes sense because of the sheer amount of work it was doing before it was just turned off, turned on, and then it died. But I'm just going to check the pins on the rest of the board because it just doesn't make any real sense at the moment. So let's have another look. I'm just going to check. You can just see here, I'm just going to check to see if we've got actually anything on the ROMs as well. So okay, so the all of the pins I expect to have something on, yeah, are actually carrying, so that's not too bad. So I got a funny feeling that it's kind of most of the board's okay. I think, sorry, the 68,000 is at fault here, but I'm just going to check one or two other pins on here just to make sure. So I'm going to go around the power and the data line on here. Yeah, that's holding steady. Okay, so it really hasn't taken that long to figure out what's going on with this board. We have a failure of 68,000, but the way it failed suggests a a failed joint on here more than anything else, a failed solder joint, because I kind of think the power's not actually getting to the chip itself. I'm going to check a couple of the pinouts which I know we really should be checking. The first one is going to be a VCC, and also I'm going to check your reset line, which your reset line's fine. Your VCC seems to be fine. Just going to check a data line, which we're dead, and that one's flatlining. That's not so good. Okay, so we'll just try the next one too, which I got a bit of a life at when I touched it on the way out. That's fine. The other one, flatlining. Okay, so it looks like we've got a CPU fault, which is what I suspected because I've actually seen this before. Now, I'm just going to check the rest of the pins just to be on the safe side. Again, that's not right. Yeah, that one's okay. Oh, there we go. Okay, so we don't have much in the way of data on a lot of the pins, so it looks like the processor's failed or failing, which is hence the caps lock on all the time. So really need to try and get this sorted out. Okay, so I believe it's the 68,000 that's causing the problem, and I know most people are going to go, well, you can't really replace that because it's a surface mount component, but from what I discovered on the old oscilloscope here is that it's not getting a connection. It's not getting any connection whatsoever on the pins that I'd expect there to be a connection on of some kind. Even if it was intermittent, even if it was bad, you should have got some kind of feedback on some of those pins. So it seems a bit odd. So what I'm going to do is a little tiny bit of a trick. But I'm going to take a hot air gun and I'm going to gently heat up the actual legs on this processor. Now you can try and do it from the other side, but the big problem you do when you do one of these from the other side is that you have the board up the other way, and what happens is you'll go too far and the processor will start to slide. All the solder that's on the pads will start to slide and come off. So really all you can't trying to do here is just gently heat the pins so that it forms a brand new connection. You're basically gently trying to reflow the joints, and most of the time that will actually do the job. So it's quite a good thing to try out, because at the end of the day this would almost certainly need to be a replacement board, which are very difficult to find. So I'm going to set this to about 303 ish, and we're just going to use a gentle bit of heat, and that's quite warm on here, and I'm just going to pop my hand here just to try and keep a little bit of the heat in. It takes a little bit of time. You don't want to overcook it. You can actually smell it when it starts to flow, which I can smell now. It's kind of something you get used to. Right, okay, so I'm going to leave that to cool off for a second or two, because you know, you don't really want to overcook it, otherwise you'll be back to square one or worse than square one, because now you've actually damaged other components on the board. I'm just checking that the rest of them are, yeah, they're relatively cool. So I'm going to give that a minute just to cool off, then we're going to plug the old board back in again and we're going to see what happens. Okay, now just plug the board in. I'm going to pop the old oscilloscope back on, because I'm just going to check those pins that had no signal on them, no connect, which should have had some data on them. So let's take a look. So it looks like we've got some data on those pins. So okay, so what I'm going to do is I'm going to try and turn the machine on. So let's get it plugged into here. It's unplug it first, get it all plugged back in, and then we'll hopefully get it all fired up. Okay, so this is the machine starting up, and it seems to be asking for a disk. So what I need to do now is to button the machine up and then give it a try. It looks like the biggest problem was it was a bad joint. It was a solder joint that basically had given up over a little bit of time. I mean, there's not a lot holding these to the board. It's a tiny bit of solder on each pad, and all it needs is one solder joint to basically degrade, and then that's it. But applying a little bit of heat can sometimes solve the problem. So let's get this machine buttoned up and let's have a look at it. Right, okay, so the machine's back together, it's all powered on. As you can see, it's working fine. Yeah, it's worth a try on these things, because as I say, surface mount processors really are almost impossible to change. As a kind of a DIY kind of hobbyist from that kind of perspective, but a lot of the times it's just old solder joints. It's just things maybe that weren't quite fully down when they were built in the factory, and they were just hanging on by a thread, and all it needed is a little bit of heat to reflow the joints and make sure that everything's fine. And as you can see, it's running really well. So I'm just going to make sure that everything's spinning up properly. I'm just going to try and load something up on the screen other than what's on the disk originally. So we're just going to see what happens, just to make sure that everything's working the way it should do. And as you can see, this is Dr. T's MIDI recording studio, which is what I'm going to have to do slightly later, just to make sure it all works. Okay. And as you can see, there we go, it's up and running. So we can successfully say that that's actually cured the fault. So this is another Amiga which has been saved from either major surgery of a new board, and then it possibly couldn't really be viewed as an original machine, but you know, it's all back together the way it left the factory. So this lives to fight another day. So I hope you enjoyed this, and I hope to see you soon, and join us on Retech again. Please subscribe, and I'll see you soon. Thank you.